So hello students, this is the continuation of the Rolle's theorem problems. Okay, so I wanted to discuss some more problems on Rolle's theorem here. Is so where you have to we need to verify the Rolle's theorem for the function f of x is equal to sin x in the interval 0 to 2 pi. Yes, to verify Rolle's theorem to the function. Okay, first to take the function f of x. So it is not a polynomial like previous problems. It is a trigonometric function. It is a trigonometric function. F of x is equal to sin x. Is f of x for all the values in between 0 to 2 pi. F of x is defined. So definitely f of x is a continuous function in the interval 0 to 2 pi. 0 to 2 pi ಮಧ್ಯದಲ್ಲಿರೋ ಯಾವುದೇ ವ್ಯಾಲ್ಯೂನ ಎಕ್ಸ್ಗೆ ಕೊಟ್ಟರು ಅದು ಸೊ ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗೋದ್ರಿಂದ ಸೊ ಯೂಶಲಿ ಇಟ್ ಈಸ್ ಎ ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್ ಆಗಿರುತ್ತೆ. ಸೊ ಯು ರೈಟ್ ಕ್ಲಿಯರ್ಲಿ f of x is continuous. f of x is continuous. Right? f of x is continuous in the interval 0 to 2 pi. So next condition is the differentiability condition. You take f dash of x. F dash of x is equal to differentiation of f of x. Differentiation of sin x is cos x. Cos x also defined in between 0 to 2 pi. So nowhere it is assumes in infinity or indeterminate forms. Okay. So you write f dash of x exits. That value exits in 0 to 2 pi open interval. So third condition, Rolle's theorem na third condition ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. So that is f of 0 is sin 0 0 ನೇ ಬರುತ್ತೆ. So next f of 2 pi is sin 2 pi. Sin 2 pi ಅಂದ್ರೆ ಅದು ಕೂಡ 0. So sin 2 pi is also 0. So that is f of 0 is equal to f of 2 pi. Therefore f of x satisfies all the conditions of Rolle's theorem. All the conditions of Rolle's theorem. All the conditions of Rolle's theorem. So then accordingly, therefore there exists c belongs to 0 to 2 pi such that Rolle's theorem ಪ್ರಕಾರ ಒಂದು ವ್ಯಾಲ್ಯೂ ಸಿ ಅನ್ನೋದನ್ನ ಎಕ್ಸಿಸ್ಟ್ ಮಾಡಬೇಕು 0 to pi ಮಧ್ಯದಲ್ಲಿ. ಸೊ ಆ ಪಾಯಿಂಟ್ ಏನಾಗಬೇಕು, ಫಂಕ್ಷನ್ನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ 0 ಆಗಬೇಕು. ಸೊ ಸಚ್ ದಟ್ f dash of c is equal to 0. f dash of x is cos x, f dash of c is cos c is equal to 0. So then what is c? C is a cos inverse of 0. C is equal to, when cos is 0, for what value of theta, cos theta becomes 0. So 0 ಯಾವಾಗ ಆಗುತ್ತಾ? So for the value pi by 2, because cos pi by 2 is 0, so cos inverse of 0 is pi by 2. So not only pi by 2, for 3 pi by 2 also 0, for 5 pi by 2 also 0. It exists many values like that. ತುಂಬ ವ್ಯಾಲ್ಯೂಸ್ ಸಿಗ್ತಾ ಹೋಗುತ್ತೆ, ಆದರೆ ನಮಗೆ ಬೇಕಾಗಿರೋದು 0 to pi, 0 to 360 ಮಧ್ಯದಲ್ಲಿರೋದು ಮಾತ್ರ. So that is, these two are the values. So therefore required values of c are values required ಹೀಗೆ ಬರೆಯೋದು ನಾನು. So values of c are c is equal to pi by 2, that belongs to 0 to pi, and c is equal to 3 pi by 2, that belongs to 0 to 2 pi. ಎರಡು ವ್ಯಾಲ್ಯೂಸ್ ಬರುತ್ತೆ. ಸೊ ಕಂಪಲ್ಸರಿ ಒಂದು ವ್ಯಾಲ್ಯೂ ಎಕ್ಸಿಸ್ಟ್ ಆಗಲೇಬೇಕು, ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆದರೆ ತೊಂದರೆ ಇಲ್ಲ, ಆಗಲಿ. Okay, so like this. So Rolle's theorem is verified. Therefore Rolle's theorem. So example RT anta everybody full form barire. So Rolle's theorem is verified. Okay, again one more problem on Rolle's theorem is verify Rolle's theorem for the function f of x is equal to x into x plus 3 into e to the power minus x by 2 in the interval minus 3 to 0. First you write f of x. So given function f of x is equal to x into x plus 3 into e to the power minus x by 2 is defined in the interval minus 3 to 0. Yes, we need to check all the three conditions of Rolle's theorem first. ಮೂರು conditions verify ಮಾಡಬೇಕು. First condition ತಗೊಳ್ಳೋಣ. So yes, for no values in between minus 3 to 0, it assumes infinity or indeterminate form. ಯಾವ ವ್ಯಾಲ್ಯೂಗೂ ಆಗೋದಿಲ್ಲ. So exponential function continuous, so polynomial continuous, so product of two continuous function may be continuous. So ಇಲ್ಲಿ ಆಗುತ್ತೆ continuous ಆಗುತ್ತೆ. So f of x is a continuous function. So clearly you write clearly f of x is continuous. F of x is continuous in the interval minus 3 to 0. Second condition, it's differentiation. So differentiation of f of x, we need to consider the differentiation of f of x. So that is f dash of x is equal to we need to differentiate first into differentiation of second into differentiation of first. Illi three functions ಇದೆ. So x plus 3 e to the power of minus x by 2. We have to use the product rule continuously 3 times. So differentiation of first, second and third constant, and differentiation of second, first and third as it is, differentiation of third, first and second as it is. ಹಾಗೆ ಮಾಡೋಣ. So differentiation of first is 1 into x plus 3 as it is, e to the power minus x by 2, you keep it as it is, plus next you write x as it is, differentiation of x plus 3 is 1 and e to the power of minus x by 2 as it is, plus in last term you write x into x plus 3 as it is, differentiation of e to the power minus x by 2 is e to the power minus x by 2. ಸೊ ಬರೀ ಇದು ಇನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್, ಇನ ಒಳಗಡೆ ಇರೋ ಫಂಕ್ಷನ್ ಮೈನಸ್ ಎಕ್ಸ್ ಬೈ ಟು. ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ದಟ್ ಅಗೇನ್. ಇಟ್ಸ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಗಿವ್ಸ್ ದಟ್ ಮೈನಸ್ 1 ಬೈ 2. ಈ ಮೈನಸ್ ಎಕ್ಸ್ ಬೈ ಟುನ ಮತ್ತೆ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡಬೇಕು, ಪವರ್ನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡಿದ್ರೆ ಮೈನಸ್ 1 ಬೈ 2 ಬರುತ್ತೆ. ಸೊ ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು, ಇನ್ ಆಲ್ ದಟ್ ಟರ್ಮ್ ಕನ್ಸಿಸ್ಟ್ಸ್ ಆಫ್ e ಟು ದಿ ಪವರ್ ಆಫ್ ಮೈನಸ್ ಎಕ್ಸ್ ಬೈ 2. ಸೊ ಯು ಟೇಕ್ ದಟ್ e ಟು ದಿ ಪವರ್ ಆಫ್ ಮೈನಸ್ ಎಕ್ಸ್ ಬೈ 2 ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್. So remaining in first term is ಏನು ಉಳಿಯುತ್ತೆ ಅಂದರೆ it is x plus 3, second term ಅಲ್ಲಿ x, and the term so remaining in third term is so minus 1 by 2 into x plus 3, or you write that is minus 1 by 2 into yes, you can write that is x into x plus 3 can be written as x square plus 3x. X square plus 3x. When you are multiplying this x and x plus 3, it is x square plus 3x. So next step, which is equal to e to the power minus x by 2 into this is x plus x is 2x plus 3, and this is minus of x square plus 3x all divided by 2. ಸೊ 2 LCM ತಗೊಂಡ್ರೆ 2 ಇಂದ ಇದು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ, ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು e ಟು ದಿ ಪವರ್ ಮೈನಸ್ ಎಕ್ಸ್ ಬೈ 2 ಇಂಟು 2 ಇಂಟು 2x ಪ್ಲಸ್ 3 ಮೈನಸ್ ಎಕ್ಸ್ ಸ್ಕ್ವಯರ್ ಮೈನಸ್ 3x. ವೆನ್ ಯು ಆರ್ ಮಲ್ಟಿಪ್ಲೈಂಗ್ ಮೈನಸ್, ಇದು ಮೈನಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಈಗ ಬರುತ್ತೆ, ದಿಸ್ ಹೋಲ್ ಡಿವೈಡೆಡ್ ಬೈ 2, which is equal to e to the power minus x by 2 divided by 2. This 2 I am writing here. So and 2 into 2x plus 3 is 4x plus 6 minus x square minus 3x. Simplifying this again, so previous problems ಅಲ್ಲಿ f dash of x ಈಸಿಯಾಗಿ ಬರ್ತಾ ಇತ್ತು, ಇದರಲ್ಲಿ ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಇದೆ, ಸೊ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ವಿಚ್ is equal to e to the minus x by 2 as it is by 2 into, as here you write it is minus x square minus 3x plus 4x is plus x plus 6. Okay, so nowhere it is infinity for in the interval minus 3 to 0. ಯಾವ ವ್ಯಾಲ್ಯೂಗೂ ಇದು ಇನ್ಫಿನಿಟಿ ಅಥವಾ ಇಂಡಿಟರ್ಮಿನೆಂಟ್ ಫಾರಮ್ ಬರೋದಿಲ್ಲ. ಸೊ ರೈಟ್ ಇಟ್ಸ್ f dash of x exits, f dash of x exits in minus 3 to 0. So and third condition f of minus 3. f of minus 3 is equal to, you see the function ಏನಿದೆ, minus x into x plus 3 into e to the minus x by 2. So you substitute there, x into x is minus 3 into minus 3 plus 3 into e to the minus x by 2. Minus of minus 3 by 2 is 0, because minus 3 plus 3 cancels, it becomes 0. 0 into anything 0 ಆಗುತ್ತೆ, ಸೊ ಇದು 0 ಆಯಿತು. ಸೊ ನೆಕ್ಸ್ಟ್ f of 0 you take, ಸೊ xಗೆ 0 ಇರೋದ್ರಿಂದ 0 into anything is 0, xಗೆ 0 ಕೊಟ್ಟರೆ ಎಲ್ಲ ಟರ್ಮ್ಸ್ 0 ಆಗುತ್ತೆ. ಸೊ ಟೇಕ್ ಇಟ್ is f of 0 is 0, that is f of minus 3 is equal to f of 0. f of minus 3 is equal to f of 0. So that is f of x satisfies all the conditions of Rolle's theorem. So then according to Rolle's theorem, it must exit a point C between ABs such that therefore there exits C belongs to minus 3 to 0 such that f dash of C is equal to 0. What is f dash? So ಇಲ್ಲಿದೆ ನೋಡಿ f dash, this is f dash, this is f dash. So f dash of C is e to the minus C by 2, e to the power minus C divided by 2 into minus C square plus C plus 6 is equal to 0. So when the product of 2 is 0 means one of the term must be 0, either this is 0 or this is 0. So exponential functions are not 0. is 0 ಆಗಬೇಕಂದ್ರೆ c infinity ಆಗಬೇಕು, but c is not infinity, so this is not 0. So if this factor is not 0, then definitely this factor will be 0. ಇದು 0 ಆಗೋದಿಲ್ಲ ಅಂದರೆ ಡೆಫಿನೆಟ್ಲಿ ಇದು 0 ಆಗಬೇಕು. ಸೊ ವಿಚ್ ಇಂಪ್ಲೈಸ್ ದಟ್ minus c square plus c plus 6 is equal to 0. And if possible, you find the value of c here. If it is possible to factorize this, you factorize and check the value. So once again we can write this as c square minus c minus 6 is equal to 0. Factorize ಮಾಡ್ಬೋದಾ, ಮಾಡಲಿಕ್ಕಾಗುತ್ತಾ? ಸೊ minus 3c plus 2c you can write. 3 to the 6, okay. C square minus 3c plus 2c minus 6 is equal to 0. Take c common factor, it is c minus 3 plus 2 na common factor ತಗೊಳ್ಳಿ, c minus 3 is equal to 0. Take c minus 3 is a common factor, remaining is c plus 2 is equal to 0. So then which implies that c is equal to 3, c is equal to minus 2. So but c is equal to 3 is not in our range. C is equal to minus 2, definitely that is the value in between minus 3 and 0. So therefore required value of c is equal to minus 2, that belongs to the interval minus 3 to 0. Sorry, it is visible or not. Yes, minus 3 to 0. C is the value, C is equal to minus 2 is the value belongs to minus 3 to 0. Hence, Rolle's theorem is verified. So, Rolle's theorem is verified. So, the last bari okay. Similarly, one more problem on Rolle's theorem is f of x is equal to x minus a whole cube into x minus b whole to the power 4. F of x is equal to x minus a whole cube into x minus b whole to the power 4. It is defined in the interval a to b. We don't know what is a and b is. So in any interval a b. So the condition is if this is a and this is b, it should be a b here. It is 3, it is 4, it should be 3, 4 like that. That problem varies. Another codely AB plus L. So be ready to solve this. Okay, first you take the continuity condition. So clearly it is a polynomial. So f of x is a polynomial in x. So hence it is continuous in the interval AB. So since f of x is polynomial, polynomial in x, therefore it is continuous. It is continuous in the interval AB. And second condition is you take f dash of x. F dash of x is equal to first into differentiation of second x minus a whole cube into differentiation of x minus b whole to the power 4 is 4 into x minus b whole to the power 4 minus 1 is 3 plus similarly. So differentiation of first into second. Differentiation of first term is 3 into x minus a whole square into x minus b whole to the power 4. You write as it is. So which is equal to. So the common term in both the common factor in both the terms is you can take x minus a whole square is the common factor. And we can take x minus b whole cube is the common factor. Okay. So then what is remaining here? So if x minus a comes outside, remaining is one more x minus a and 4. 4 into x minus a is remaining in first term. In second term, x minus a completely comes outside. So in x minus b whole to the power 4, we are taking x minus b whole cube common factor. So remaining here is 3 into x minus b, which is equal to x minus a whole square into x minus b whole cube into, you multiply this, it is 4x minus 4a plus 3x minus 3b. Again, simplifying this, x minus a whole square into x minus b whole cube into 4x plus 3x is 7x. 7x minus 4a minus 3b. 4a minus 3b. Yes, definitely it is also a polynomial. So this polynomial exits. That exits in the interval AB. That means the function is differentiable in the given interval AB. So next, third condition. We need to verify the third condition of Rolle's theorem. So that is, you take third condition. You take f of a. F of a is equal to, in place of x we have to take x a. So it is a minus a whole cube into a minus b whole to the power 4 is 0 because a minus a is 0. Similarly, f of b is equal to b minus a whole cube into b minus b whole to the power 4 is 0 because b and b cancels, it becomes 0. So that is f of a is equal to f of b. F of a is equal to f of b. So f of x satisfies all the conditions of Rolle's theorem. Therefore, there exists at least one point C. Therefore, there exists C belongs to AB such that f dash of C is equal to 0. What is f dash of x? F dash of x is x minus a whole square into x minus b whole cube into 7x minus 4a minus 3b. So f dash of C is also C minus a whole square into C minus b whole cube into 7c minus 4a minus 3b is equal to 0. So what it implies? C minus a is equal to 0 or C is equal to a. C minus b is equal to 0 or 7c minus 4a minus 3b is equal to 0. So Rolle's theorem says that it exits a value in between AB. AB ಅಲ್ಲ, AB ಮಧ್ಯದಲ್ಲಿ ಒಂದು ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ ಅಂತ ಹೇಳೋದು Rolle's theorem. ಬಟ್ ನಮಗೆ AB ನೇ ವ್ಯಾಲ್ಯೂ ಬಂದರೆ ಸೊ ದಟ್ ಆರ್ ನಾಟ್ ದ ರಿಕ್ವೈರ್ಡ್ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ ಸಿ ನ ವ್ಯಾಲ್ಯೂಸ್ ಅಲ್ಲ ಅದು ಬಿಟ್ಟು ಬೇರೆ ಬರಬೇಕು, ಅದು ಮಧ್ಯದಲ್ಲಿರೋ ವ್ಯಾಲ್ಯೂಸ್ ಬರಬೇಕು. ಸೊ ದಿಸ್ ಈಸ್ ನಾಟ್ ದ ವ್ಯಾಲ್ಯೂ. ಸೊ ದೆನ್ ಯು ಚೆಕ್ ದ ಥರ್ಡ್ ಕಂಡೀಷನ್, ದಟ್ ಈಸ್ 7c minus 3a minus 3b is equal to 0. So find C. 7c is equal to 4a plus 3b. C is equal to, it is 4a plus 3b divided by 7. Is actually this is the point belongs to AB. ಸೊ ಯಾಕೆ ಎ ಬಿ ಮಧ್ಯದಲ್ಲಿರುತ್ತೆ ಅಂತ ಯಾವ ಕಾನ್ಫಿಡೆನ್ಸ್ ಮೇಲೆ ಹೇಳ್ತೀವಿ ಅಂತಂದರೆ, ಸಪೋಸ್ ದಿಸ್ ಇಸ್ ದ ರಿಯಲ್ ಲೈನ್ with points. This is the real line with points some x, y. Okay, this is x and or you take it is x1, this is x2. So and C is the point. It divides this line in the ratio m and n internally. C is the point, it divides x1, x2 internally in the ratio m and n. Then C is equal to mx2 plus nx1 divided by m plus n. Similarly here, so here AB is divided by, so here C can be written as 4a plus 3b divided by 4 plus 3. 7 can be written as 4 plus 3. It is sorry, I think it is not possible to see. Okay, yeah, now you can see this is 4a plus 3b divided by 4 plus 3. So 7 can be written as 4 plus 3, right? Yeah. So now C is the point, definitely belongs to AB because C is the value, it is like mx2 plus nx1 by m plus n. So definitely C is the point, divides the line between AB, divides AB internally in the ratio 3:4. So this is because C is equal to, this belongs to AB because C divides AB internally in the ratio m:n, that is 4:3. ಸೊ ಇಂಟರ್ನಲಿ ಡಿವೈಡ್ ಮಾಡೋದ್ರಿಂದ ಮಧ್ಯದಲ್ಲಿ ಇದ್ದೇ ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ತೀವಿ, ಎಕ್ಸ್ಟರ್ನಲಿ ಅಲ್ಲ, ಮೈನಸ್ ಬಂದರೆ ಅಲ್ಲ, ಇಂಟರ್ನಲಿ ಡಿವೈಡ್ ಮಾಡೋದ್ರಿಂದ. ಓಕೆ. Okay, for this reason that value of C belongs to AB, hence Rolle's theorem is verified. Hence I know it is a lengthy problem, hence Rolle's theorem is verified. 5 marks ಕೇಳಿದ್ರೆ ಈ ಥರ ಕೇಳ್ತಾರೆ. Verified. Sometimes asked very easy problems also. Yes, one more problem on Rolle's theorem is f of x is equal to x minus 1 x minus 1 to the power 2 by 3. So it is defined in the interval 0 to 2. So first condition you write continuity condition. So clearly f of x is continuous. Clearly f of x is continuous in the interval 0 to. Second condition is differentiability condition. F dash of x is equal to differentiation of 2 is 0 plus differentiation of x minus 1 to the power 2 by 3 is 2 by 3 into x minus 1 to the power 2 by 3 minus 1. Again differentiation of x minus 1 is 1. Simplifying this, it gives that 2 by 3 into x minus 1 to the power minus 1 by 3. So that is the value. Is that value is 0 or infinity, anywhere in between? Yes, I think this function is not differentiable at x is equal to. This function is not differentiable at x is equal to 1. You go and verify this. So it is a 2 by, ಯಾಕೆಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ cube root of this can be written as cube root of x minus 1. When you bring this one to denominator, it is x minus 1 to the power 1 by 3 can be written as cube root of x minus 1. So 0 2 ಮಧ್ಯದಲ್ಲಿ 1 ಇದೆ, 1 ನ x ಗೆ ಕೊಟ್ಟರೆ 1 minus 1 becomes 0. 2 by 0 is infinity. So we are getting infinity at x is equal to 1. So you check left hand derivative and right hand derivative for the point x is equal to 1. So I think they may be not same. Left hand derivative, right hand derivative find out ಮಾಡಿದ್ರೆ so x is equal to 1 ಗೆ so same ಬರೋದಿಲ್ಲ ಅನ್ಸುತ್ತೆ. So the given function is not differentiable function, differentiable ಆಗಲ್ಲ function. So function differentiable ಆಗೋದಿಲ್ಲ ಅಂತಂದ್ರೆ it is the, so one of the Rolle's theorem condition fails. One of the Rolle's theorem condition fails. So Rolle's theorem conditions fail ಆಯ್ತಂದ್ರೆ ಮತ್ತೆ so c value exist ಆಗಬೇಕು ಅಂತ ಇಲ್ಲ. So you write the conclusion, f of x is not differentiable. F of x is not differentiable. It is not differentiable at x is equal to 1. So therefore f of x fails to satisfy conditions of Rolle's theorem. F of x fails to satisfy the conditions of Rolle's theorem. So it is not necessary to check third condition. So one condition fail ಆಯ್ತಂದ್ರೆ ಬೇಕಾಗಿಲ್ಲ, ಅದು ವೆರಿಫೈ ಆದ್ರೂ so Rolle's theorem is not applicable here. Okay, so these are some problems on Rolle's theorem. I wanted to continue some more problems on Rolle's theorem. So in next class I will discuss some more problems on Rolle's theorem. So hopes you understand. ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದ್ರೆ ಒಂದಿನ ಆನ್ಲೈನ್ ಕ್ಲಾಸ್ ಇಟ್ಕೊಂಡು ಡಿಸ್ಕಷನ್ ಮಾಡೋಣ. ಸೊ ಜಸ್ಟ್ ಹಾಫ್ ಆನ್ ಅವರ್ ಡಿಸ್ಕಷನ್ ಸೆಕ್ಷನ್ ವೈಸ್ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. Okay, I want to stop.